Okay, 1, 2, 3. Okay, seems like we have set it up, so we can probably start. Hello everyone, my name is Valentin, and I'm a founder of Novasama Technologies and Android lead at Nova Wallet. So today I want to share with you our experience at building decentralized and user-friendly client applications for Substrate Networks. So firstly, we will start with some quick overview of client applications in Web2 world. I'm sure most of you have started your careers working with Web2, so we'll just quickly recap it. Then we'll compare it with Web3 experience. After that, we will dive into client development for Substrate Networks. And finally, we will discuss some tips and tricks on how we approach development in Novasama. So let's start with an overview of client applications in Web2. In Web2, it's actually pretty simple. We usually have a client app that communicates with some web server that has some API in the form of REST, GraphQL, or RPC, and designed to support main use cases of your application. It's pretty easy, and usually Web2 applications are pretty simple, and the most complicated part lies on a web server itself. Good Web2 APIs are also versioned and backward compatible, so all good for client applications. However, things are pretty different in Web3. And because in Web3, we have a blockchain as our primary source of data. And most of the blockchains communicate with their clients by means of JSON RPC 2.0 protocol. On the slide, you can see an example of a request and response for JSON RPC for Polkadot. And blockchain APIs, on-chain APIs, have some major downsides. In particular, RPC call list is not exhaustive to support all application use cases. So you would imagine blockchain supposed to have a separate RPC for fetching all transactions for a user to let clients support it pretty easily, but they don't usually have it. And also, on-chain state is structured to facilitate efficiency in the first place and not usability. So while some information might be exposed to you from a blockchain, in a lot of cases, it won't be feasible for you to fetch it in a reasonable amount of time. So let's consider some practical examples of what I just said. For example, we are a wallet team and want to develop some basic wallet functionality. So first of all, we want to display user his balances. For that, we want to basically real-time updates of those balances, and we need to subscribe to them. It's pretty easy, actually, on most of the chains. Similarly, observing transaction updates are also pretty easy and introduce no major issues. However, things start to get more interesting when you, for example, try to fetch NFTs. It is pretty easy on some of the chains, like StateMine, which is a Polkadot parachain. But on others, like Ethereum, it becomes more complex and requires a lot of manipulations on the client side to achieve. And finally, there are some use cases which are really hardly feasible on a client application side. For example, in order to fetch your transaction history from on-chain, you should basically analyze all block store and find relevant extrinsic transactions, which is obviously not achievable in a reasonable amount of time. Yeah. So that's why we use off-chain data providers, such as indexers, for example, which allows you to fetch some historical or aggregated information, which is things from on-chain. I would split all indexes into two groups. First one is like general purpose API, which is like Subscan, which offers you a general purpose API for some common use cases like fetching all transactions, rewards, or whatever. However, it is not. It might not fit all of your use cases. So in that case, you should consider writing your own indexing logic using subquery or subscript. The second group of off-chain data providers are price providers. They are useful because blockchain usually don't have a notion of price for a token. So that's why it's useful to use these providers in order to enhance user experience. CoinGecko and CoinMarketCap are kind of aggregated APIs which offers you an averaged prices over multiple sources, but at the same time they are updated like a half a minute or something, so it's might not suit for all use cases. So you might consider using SEX APIs directly. For example, Binance Spot Trades, which is like real time and can be updated once a second or something. And the last group of off-chain providers I want to mention here is file storage. So on-chain storage and space is pretty expensive, so we cannot really store large blob of data directly on-chain. And for that reason, the common approach is to store those blobs somewhere else, like hopefully in some distributed storage, and only store a reference to a file on-chain. Most known example of such distributed storage is IPFS, which is a immutable distributed file system which allows you to just store a file and don't really care that it will be lost anywhere in the future if you do it right. And now let's jump into an overview of how client applications work for a Substrate chain. We will start with reviewing a structure of Substrate networks for everyone to be on the same page. So every Substrate network is divided into multiple modules called pallets, which are building blocks of a network, and usually they're focused around a single piece of functionality in a network. For example, you might think of some pallets like balances, staking, and governance available on a single chain to offer different functionality. Each pallet itself has multiple components which we as a client developers can interact with. I guess the major one of them being storage. Basically, it's a place where all chain-specific information is stored. Storage is basically a set of dictionaries, generalized dictionaries with a set of keys and a value. So here you can see an example from a staking pallet where some storages have no keys. In that case, it's kind of a constant storage, single value storage, I mean. Then you might have a storage with a single key, with two keys, with three keys, and actually it's not bounded, but usually you won't see more than 3 keys in a single storage. The next important component of each pallet are calls. Call is basically action that user can execute in order to change on-chain state. A simple example of a call is a transfer call from assets pallet, which allows user to transfer funds from one place to another. On the other hand, calls can be nested to achieve more complex use cases. For example, there's an utility pallet which offers several batch something operations, calls I mean, to help you to perform atomic operations, like executing multiple calls in advance. The next component is event. So an event is an entity that helps you to understand that something actually happened during call execution. Events are stored on in a special storage inside the system pallet. Events are quite useful when it comes to indexing, because events are more robust when it comes to tracking certain actions. You can track transactions too, but as I said previously, calls can be nested. So you will need to implement a very complex logic on how to handle nested calls that can be infinitely nested in each other, actually. So that's why tracking events is more robust, especially considering that For example, transfers might not only happen directly as a result of user action. And last one are errors, which can help you to understand that something went wrong during call execution. Errors are actually a specific kind of event that's emitted on an unsuccessful call execution. However, I would strictly advise you to not rely on a chain to throw an error in case of something went wrong, because it will result in a in a user losing some amount due to fees. So it is actually better to study logic which is held on-chain and implement client-side validations to prevent user from making those mistakes, like trying to transfer more funds that he or she currently has, to avoid losing commission for an unsuccessful transaction. So now, after we quickly checked how Substrate Networks work and what they consist of, let's talk about Substrate palettes, ABI changes, and versioning. And actually, it's not that great, because Substrate palettes doesn't allow us to version our code and our API in a Web 2 way. While there's a special constant called palette version exists on each palette. It's just a number. And if you implement a breaking change in one of your palettes, it won't magically help you to let older versions of your clients remains compatible. So that's why you should actually think about forward compatibility when developing your applications. For example, if your client application relies on some storage, which might potentially will be changed in the future, you should gracefully handle decoding and fetching errors and not break your and not let your app being halted because of some issues related to potential breaking changes in the future. So now let's discuss some tips on how which we use at Novasama and which we developed during our 3-year development experience in Polkadot. So first of all, we use blockchain as a primary source of truth for our applications. It allows us to maintain 2 important quality attributes, which are availability and real-time updates. For availability, we basically should not depend on our app availability should not depend on external services like price providers or transaction history providers. Those are auxiliary features that should not be dependent for crucial parts of your app. And real-time updates are achievable by subscribing to on-chain state due to low latency between chain actually processing the update and application receiving it. Off-chain sources will have a higher latency because of indexing overhead. It usually might be actually up to 20 seconds for an indexer to receive an update about your transfer or anything else. Because indexers usually only consider finalized blocks. So a block that successfully passed consensus verification. However, we still rely on some auxiliary data sources, but as I said, we do not consider them a crucial part of the app. So each of each of data sources I will mention, each failure of such data source won't break our applications. So I would split data sources that we use for 3 main categories. First one is data sources that help us to fetch information that is not available on-chain at all. For example, prices or referendum metadata in governance. Then there is a certain group of providers that allow us to fetch information that is really hard to fetch from a blockchain, like transaction history I've mentioned earlier. Lastly, we use some providers to help us speed up fetching certain information retrieval. However, still having on-chain fallback in case the off-chain provider goes offline. A good example here will be referendum votes. So referendum votes are stored on-chain in a way that's really hard to fetch all votes for a given referendum. You'll actually need to fetch all votes in an entire network. So it's pretty time-consuming operation. While we still use this approach for a fallback, we rely on off-chain indexing for faster fetching it in a good path in case our indexer is healthy. So now, when we talked about multiple ways to achieve optimizations and better user experience, let's talk about subquery indexers. We use them a lot, and here I want to give you some tips on how you can make your life easier when developing a subquery indexer. So the main point here is that both subquery and subscript have greatly optimized indexing when it comes to indexing a certain transaction, certain event, or basically a small subset of information in general. So that's why you should target indexing a specific event or a specific transaction rather than each block in general. I mean, it will result in significant improvement. Like if you 100 times, it might be up to a few hundred times faster if you index with the help of subquery and subscript dictionaries. However, you might not need to implement it by yourself because Nova hosts a lot of infrastructure which we use for our project. However, it's available for everyone. For example, we have a subquery Nova, which is an indexer with transaction history, staking rewards, and more. We also have a governance indexer, which indexes all referenda votes as well as delegations, and basically can help you to implement fully featured governance UI for Polkadot. We also have a multi-chain staking project, which can help you to fetch APIs, staking status, and rewards for multiple chains in a single request. It is useful for developing multi-chain applications, which is Polkadot is heading towards too. And finally, we have some utility packages like a subquery call wizard, which actually allows you to traverse nested calls inside transaction in case you really need it. So here's our infrastructure, and we would like to builders from community to use it, and we're eager to help you integrate it into your own applications. And the final topic I want to cover today is the client-side caching. So caching is the most important technique, I would say, in client-side application development because it can allow you to greatly improve user experience. Even if your server is slow, it is down, or whatever, caching can really soften it out. So the main problem in caching is actually when you want to invalidate it. So in a substrate specifically, when you will think about caching, it will mostly come down to caching some information available in the on-chain storage. In that case, we have several options. Firstly, we might need to sync a specific storage key. In that case, we can just subscribe to it and store updates to cache. So no need to think about invalidation at all. Syncing multiple keys is similar. However, I'm advised to consider multi-subscription capabilities to subscribe to multiple keys in a single request rather than sending multiple requests in a row. Things get more interesting when we go to syncing case by prefix, because Substrate currently doesn't allow us to subscribe to a keys by their prefix. So you need to try to find another way on how to invalidate the cache. For example, if you want to subscribe to active stakers from the staking palette, you might want to subscribe to active era index instead, and on each active era update, fetch new active era stakers since they update at the same time. And this technique applies in almost all of the other use cases. You can find some other storage that updates and can be subscribed at. There's also notion of child state, which is primarily used for cloud loan contributions now, but might be used for something else in the future. It also doesn't have a subscription yet, so you need to use the same approach as this prefix syncing. Now, when we know how to sync and validate cache, we need to discuss how to actually store the data. And for that, I would highly recommend you to not put everything into relational cache, because there's a lot of entities, and we'll come up with a really huge relational tables. So you should consider putting data in relation cache only for those parts which will be used for some complex queries. For example, we use relational cache for things related for focus around accounts like balances and NFTs. Everything else can be put into prefix search key value in cache. On a mobile, choice is not very wide, so we use SQL-Lite database with a battery index on a table. And but on desktop, you can actually you have more options. You can use some key value storages with a prefix optimized search, which are better option actually because they are faster and they are specifically targeted over such kind of use cases. And that's all from my side. Thank you everyone for attention. We have like 5 minutes for answering your questions if you have any.
Awesome. Thank you very much, Valentin. Any questions? I will run the microphone over to you. Got one at the front here.
Thank you for the presentation. I'm a mysterious person from the crowd, but I wanted to ask you to emphasize more about the errors in terms of like the client validation side. You mentioned it, but maybe you can give some more examples of such client validation so that people will not waste their commissions by sending the transaction which will fail on the chain. Can you give us examples?
Yeah, so the most obvious example is when you are trying to send more funds than you currently have. It will obviously result in on-chain failure. So that's a typical validation you will apply to a transfer flow. However, there are some non-obvious examples specific to Polkadot. Like, I think some of you know about a thing called existential deposit, which doesn't allow you to basically to remain less than one DOT in your account. And not only it is like not obvious for a user at all, it gets worse because it actually might not even fail your transfer when you tries to transfer amount less than one DOT to another user. It might actually result in like just funds being burned at all. So that's why it's important to study a call you want to do and apply corresponding validations on the client side, because they might result in a really crucial issues for a user.
Thank you. Just expanding on what you just said. So you said it's important to study, so it means that you need to actually kind of know which call or important or what to check for before doing the call, etc., right?
Yep. So currently there's no kind of documentation for calls in Substrate network runtimes. However, Substrate runtimes are written in Rust, and it's really easy to read. So basically, you just go to source code of a specific call and Ctrl F for or ensure clauses to check what might potentially go wrong there. So it's not that hard, but I would really like to have some sort of documentation on that. Maybe we can cooperate with Parity on that in that direction.
Any more questions? Maybe not. Thank you very much. Guys, give it a round of applause one more time for Valentin from Novasama Technologies.